Hi. I asked you to try this question, and you have to think about the new event, defined as f cap h complement. So let's think about the event step by step, f and h. So I will color the outcomes that fall into each event. So think about f, event f includes these two outcomes. Now think about event H. H includes these two outcomes. And if you take complement, you will have these two outcomes. So H included these two, so the others are included in H complement. And then we have H complement and F. F is here, H complement is here. Now you have to take their intersection. Intersection of F and H complement is F and H complement. So we are taking the outcome that are included in both F and H complement. So excuse me. The the answer is 13.8%. So that's the event denoted by this way. So I hope you get what I'm saying, and it's working with this notation is important to a more complicated analysis. So and so far I have used just a very general uh, principle. So I identified which outcomes are included in the event, and then uh, and when you identify those outcomes, then sum the probabilities of those outcomes. Then that is the probability of the event. It is very easy. Uh, but here I have another formula. I have another formula you may utilize in some cases if the probability table is not present, for example. So now I'll call this general addition rule. The general addition rule is about the relationship between the probability of union and two basic probabilities. Um, so first, the union is always greater than uh, the single event, the basic event. So it starts from addition, but you have to subtract something. Let's go back to our definition of union. Here, union is defined this way. Union is defined in this way because theme H includes these two outcomes. Like F includes these two outcomes, and H includes these two outcomes. So F and H are combined. So you, in the end, included three outcomes. So F includes two outcomes, H includes two outcomes, and the union includes three outcomes. So one outcome is double counted, included twice. That is this guy. 36.72 was counted twice because it is included in both F and H. The therefore when you calculate the probability of the union, it equals to the sum of two basic probabilities minus the double counted part. You have to uh, offset the double count overlaps. So so the last one is subtracted to cancel out the double counted overlap. So that is the idea of this general addition rule. We call this addition rule because basically the basic idea of this rule is about the addition of two probabilities, and we call this general because it applies to any case. And I am going to restrict the rule to a special case, and I'll call this a special addition rule. And what we actually wanted was something like this. The probability of union equals to the sum of two probabilities. If you want to have this, then you have to have another assumption. The assumption is that there is no overlap, there is no double counting. That means the intersection has to be probability 0. If the intersection has no probability, then this term goes away. So simply it simplifies to the sum. So you need this assumption. And this assumption implies that two events do not happen at the same time. Remember, the definition of intersection was that two events happen together. And here we are assuming that the probability of that equals to 0. So that means the two events do not happen together. Its probability is 0. So that is this condition. And in this special relationship between F and H is referred to as mutual exclusiveness. So we say F and H are mutually exclusive if they do not happen at the same time. And they are mutually exclusive because when F happens, automatically it means H does not happen because they cannot happen at the same time. So mutually exclusive because they do not happen together. They are never together. So that's the definition of, like, that's the how we call this relationship. By the way, I'm using the same notation of F and H, but in our example, F and H, this assumption does not hold. F and H happens together. Calculated we already calculated the intersection probability is 36%. It is not 0. So F and H are not mutually exclusive in our example. But there are some examples. Uh, if this assumption is satisfied, that means the two events are mutually uh, mutually exclusive, and then you can apply the special addition rule, which is very simple, very nice, right? So I'm going to stop here, and I say these videos up to here are for this Thursday class if we were in classroom, and the other part of the remaining part of the this chapter is for next week, Tuesday next week. So and if you have any questions, please let me know. I would be more than happy to help you. And I'm going to upload the assignment from chapter 1, and I will make them available maybe during this weekend. I will try. Okay, thank you for watching this and have a great weekend. Bye.